Let's talk about linear functions now. This question says the function g is defined by g of x equals 4x minus 20. What is the x-intercept of the graph y equals g of x in the xy plane? So remember, the x-intercept is the coordinate when y equals 0, right? So if we have g of x equals 4x minus 20 and y is equal to g of x, what we can do here is set g of x equal to 0, right? Because remember that g of x is equal, y is the same thing as g of x basically, right? So g of x equals 4x minus 20. We're going to set g of x equal to 0, and we're going to solve for the x value that causes g of x to equal 0. Remember that x-intercept is when y equals 0, and the y-intercept is when x equals 0, all right? So you want the other variable to equal 0. Back to this one. We set y equal to 0 because we want to know, what x value causes y to equal 0. Well, I'll start off, all I need to do is solve for x, right? So I'll start off by adding 20 to both sides, and I get 20 equals 4x. Then I'll divide both sides by 4, and I get x is equal to 5, right? So when x equals 5, y equals 0. So my x-intercept is going to be the point 5 comma 0. Okay, so if we go back to our problem now, we can see that that's going to be this point. We can also graph it and find it like that. If we graph 4x minus 20, you can see that this graph intersects the x-axis at the point 5 comma 0. So we can see that when y equals 0, x equals 5. So that would be my answer. Okay, this question says an event planning company determines that the total expense E of N in dollars for organizing a wedding reception is given by E of N equals 45N plus 2500, where N represents the number of guests. What is the total expense for a wedding reception with 180 guests? So we can see that the total cost for this wedding is modeled by this linear equation, right? This linear function. And it looks like, this written in slope intercept form. So this is our slope 45, and this is our y-intercept 2500. So if you think about how to interpret that, the y-intercept, remember, is sort of the initial amount, right? So if the initial amount is 2500, that's like saying that the initial amount for maybe like hiring these or like organizing this wedding reception, the base cost is 2500, and then plus $45 for every guest on top of that, right? So that's how we can sort of interpret this situation, and we can see that n is representing the number of guests and E of n is the total cost. So when it's asking what is the total expense for a wedding reception with 180 guests, that means that we want to plug in n equals 180, right? So we just want to take this equation and replace n with 180, and we want to see what is the total cost for that, right? So if we do that, what we do is we first can write down the equation 45n plus 2500, and then what we can do is I'll take this n value and I'll replace it with 180 because that's how many guests we want, right? If I wanted 200 guests, then I would replace this with 200, but I want 180 guests, so I replace n with 180 and I get 10,600. So that's the total cost for 180 guests. Okay. This question says a maintenance crew is draining a swimming pool for repairs. The equation represents the volume of water V in gallons remaining in the pool after T hours of draining. V equals 1500 minus 200T. The equation graphs as a straight line in the coordinate plane. What does the t-intercept represent in this situation? Okay, so we can see that we have this linear relationship between the time since they started draining and the volume of water remaining, right? And it's modeled by V equals 1500 minus 200T. So this is a linear relationship and it's written in slope intercept form, right? Even though um, we're used to seeing y equals mx plus b, in this case, it's the variables are v and t, but it's still the same concept. So we have the equation v equals 1500 minus sorry, I forgot the rest of 1500 minus 200T, right? So let me write that down. 1500 minus 200T. Okay, so I can rearrange this equation slightly just so that it's more obvious to us, that it's written in slope-intercept form, I can write it as v equals negative 200t plus 1500, right? So you can see that this is clearly written in slope-intercept form, right? Y equals mx plus b. In this case, though, our independent variable is represented by t instead of x, and our dependent variable is represented by v instead of y. But again, it's still the same concept. So if I wanted to interpret this, right, we can see that my slope or my m value is negative 200, and my y-intercept, or in this case my v-intercept, because my dependent variable is v, my v-intercept is 1500, right? So if we think about what that means in this context, slope of negative 200 means that for every 1 hour that goes by, the volume of water in the pool decreases by 1500, or sorry, but decreases by 200, right? The slope is negative 200. So, I can write it like this, negative 200 over 1, right? And this is a change in v over the change in t, right? Before we had like the change in y over the change in x, but in this case, again, our variables are replaced, so it's now the change in v over the change in t, right? So for every 1 hour that t increases, in other words, for every 1 hour that goes by, the volume of water decreases by 200 gallons. So that's how we can interpret the slope. Now for the v-intercept, you can think of this as, remember, the v-intercept or the y-intercept is the initial amount, right? So in this case, it would be the initial amount of gallons in the pool, right? But that wasn't the question. If we go back to the question for a sec, the question is asking, what does the t-intercept represent in this situation? Not the v-intercept, but the t-intercept. So let's think about what that would mean. Remember that, just like before, where we said that the x-intercept is when y equals 0 and the y-intercept is when x equals 0, the t-intercept is going to be where v equals 0. So let's think about what that would mean. What does it mean for v to equal 0? Well, we know that the volume equals v represents volume, right? So when v equals 0, it means that the volume is equal to 0, right? In other words, there's no water left in the pool. So if I wanted to know, what does the t-intercept represent, I would say that how many hours does it take for the volume to equal 0, right? So that's sort of how I would interpret that, right? And why don't we actually solve for the t-intercept? So I'm just going to set v equal to 0 and solve for t, right? So I get 0 equals negative 200 t plus 1500. I solve for t, right? I start by subtracting both sides by 1500, and I get negative 1500 equals negative 200 t. And if I divide both sides by negative 200, then I get that t equals 7.5. So in other words, after 7.5 hours, the volume of water in the pool is equal to 0. So it takes 7.5 hours to completely drain the pool. Now if we go back to the question, that's going to be answer choice A, right? The pool will be completely drained after 7.5 hours. That's correct. But we can also look at the other question, the other answer choices. B says the crew drains approximately 7.5 gallons per hour. No, that's incorrect. That would represent the slope, right? Because slope is the rate of change, right? We said that, but even this would be incorrect, right? Because we said that the slope was negative 200. In other words, after every hour, the pool is drained by 200 gallons, right? So the slope is not 7.5, it's negative 200, right? So this would be incorrect in both counts, right? Also, I mean, this one would also be incorrect, although it is, using the correct slope. That's not the correct interpretation of the t-intercept. Remember, the t-intercept is just how many hours does it take for the volume to equal 0. We're not asking about the slope. Again, C is talking about the slope, not the t-intercept. D says the pool initially contained 1500 gallons of water. This is actually referring to the v-intercept, right? The initial amount of water in the pool, that's a v-intercept, right? That's 1500. But we don't care about the v-intercept in this case. We care about the t-intercept. So we would stick with A. Okay, next one. This question says, the function g is defined by g of x equals 5x plus 20. The graph of y equals g of x in the xy plane has an x-intercept at a comma 0 and a y-intercept at 0 comma b, where a and b are constants. What is the value of a plus b? Okay, so basically what we're asked to do here is find the x-intercept and the y-intercept and then add them together, right? So again, the x-intercept is just when y equals 0, the y-intercept is when x equals 0. So if you have the function g of x equals 5x plus 20, we can start by finding the x-intercept, if I find the x-intercept, I just want to set y to equal 0 and solve for that, right? So 0 equals 5x plus 20, and then just solve for x, right? Negative 20, I subtract 20 from both sides, negative 20 equals 5x, divide both sides by 5, and x equals negative 4. So my x-intercept is negative 4 for x and 0 for y, right? Now for my y-intercept, I want to set x equals 0, right? So I'll do g of x equals 5 times 0 plus 20, and I'll just solve for what g of x is, right? So g of x equals 0 plus 20, or 20, right? So my y-intercept is going to be 0, comma 20, right? When x equals 0, y equals 20, and when y equals 0, x equals negative 4. And remember that they said that, this point was like a comma 0, and this point was 0 comma b. So all I need to do, I know that my a value is now negative 4, and my b value is 20. So if I want to find a plus b, I just add negative 4 plus 20, which is going to be 16. So that should be my answer. So yeah, it would be 16. And again, we can also verify this on the graph. If we graph 5x plus 20, the way that we can find the x-intercept graphically is see where the graph crosses the x-axis, right? Because you'll notice that when the graph crosses the x-axis, y is equal to 0. So we can see that the x-coordinate of the x-intercept is negative 4, right? And for the y-intercept, when x equals 0, we see where the graph crosses the y-axis, which we can see is at 0 comma 20. So if you add these 2 points together, negative 4 and 20, then you get 16 as well. Okay, next question. This one says the functions p and q are defined as p of x equals 1/3 x minus 6 and q of x equals 2/3 x plus 15. If the function r is defined as r of x equals p of x plus q of x, what is the x-coordinate of the x-intercept of the graph y equals r of x in the xy plane? So basically, we have two functions, p of x and q of x. We want to add these two functions together in order to get a new function, r of x, and then we want to find the x-intercept of that new function, r of x. So let's do that. So remember that we have p of x equals 1/3 x minus 6, and q of x equals 2/3 x plus 15, and r of x equals p of x plus q of x. So we can actually just add these two functions together, and that'll give us r of x. So if I add, we know p of x is 1/3 x minus 6, and then I'm going to add to that q of x, which is 2/3 x plus 15. That's going to be equal to r of x. So if I combine like terms here, 1/3 x plus 2/3 x is 3/3 x, and then negative 6 plus 15 is plus 9, right? Now 3/3x is just the same thing as 1x, or just x, right? So we can say that r of x equals r of x equals x plus 9, right? And we were asked to find what is the x-intercept. Well, the x-intercept is the point where y equals 0, right? So I'll set r of x equals 0, and 0 equals x plus 9. If I subtract 9 from both sides, I end up getting x equals negative 9. So when x equals negative 9, r of x equals 0. So this would be my x-intercept, or the x-coordinate of my x-intercept would be negative 9. And I can also do this graphically using Desmos. The way that you can do this using Desmos is first you can put in the function p of x equals 1/3 x minus 6, and then you can write q of x equals 2/3 x plus 15. Then you can actually define a new function r of x, and you can say that that's equal to p of x plus q of x, and we're allowed to do this because we already defined p of x and q of x. So Desmos is going to automatically give us, or automatically calculate the function r of x for us, right? And you can see that we have three graphs plotted now, right? We have P of X, Q of X, and R of X. I'm going to hide P of X and Q of X because we're not interested in those once we found R of X. Once we know what R of X is, we just want to know what is the x-intercept of that. And we can see that the x-intercept is indeed at negative 9 comma 0. So the x-coordinate of the x-intercept is just going to be negative 9. So again, you can use Desmos for this as well. We can see that that is correct. Okay, last question. A market researcher modeled the sales S for a certain item as a linear function of the advertising budget A. The sales were 12,000 units when the advertising budget was $30,000, and the sales were 18,000 units when the advertising budget was $50,000. Based on the model, what are the sales in units when the advertising budget is 45,000? Right, so if we digest this information, we can see that this is a linear function where S is the dependent variable and A is the independent variable, right? So changes to the advertising budget will affect the sales of the item, right? And we can see, like, if you translate this information into math, you can see that they're giving us two coordinate points here, right? That the sales are 12,000 units when the advertising budget is 30,000. So that could be the point 30 comma 12,000, right? Because when advertising budget is 30,000, the sales are 12,000 units, and when advertising budget is 50,000, sales are 18,000 units, right? So why don't we write this down to make it more clear? They told us that sales are 12,000 when budget is advertising budget is 30K or 30,000, right? And sales are 18,000 when advertising budget is 50,000. Okay. So this is the information that we're provided, and they're asking us what are the sales when the budget is 45,000. Okay, so what we want to do here is we want to write a linear equation relating the sales S and the advertising budget A. So just like how we can write a normal linear equation in the form y equals mx plus b, I'm going to write the relationship between sales and advertising budget as S equals m times A plus b, where S is our dependent variable and A is our independent variable. So remember that you can find a linear equation if you have 2 points. If you're given 2 points, then you can basically find the linear equation. All right, so let's see how we can do that. Remember that this point here, $12,000 of sales when the budget is 30K, I can write that as 30 comma 12. And by the way, I'm not writing it as like 30,000 comma 12,000. I'm writing this in terms of thousands of dollars. Okay, so just to make it easier on ourselves, I'm not going to write 30,000 comma 12,000. I'm just going to I'm going to consider this as 30,000 or 30K 12K, right? So think about it like that. And then sales are 18,000 when budget is 50,000. So I can say 50 comma 18. So when advertising budget is 50,000, sales are 18,000. By the way, I realize that this may be confusing because I put 30K and 50K. K in this case is not a variable. I'm just using it to represent thousand, right? You might have heard the term like 1K or 2K or whatever. And 1K is $1,000, 2K is $2,000, whatever. That's what I meant by K. I realize that that's confusing, so I'm just going to replace it with 30,000 and 50,000. So sales are 12,000, my budget is 30,000, and sales are 18,000 when budget is 50,000, right? And again, when I'm writing the points and when I'm writing my equation, I'm just going to have sales in terms of thousands and advertising budget in terms of thousands, just to make the numbers a little bit shorter. So again, we we can get these 2 points from the information that they give us, right? So 30 comma 12, which means that when the advertising budget is 30,000, the sales are 12,000, and when advertising budget is 50,000, the sales are 18,000, right? So if you're given these 2 points, you can find the slope, right? Remember, slope is change in y over change in x, or in this case, it's going to be change in sales over change in advertising, right? You always want to do change in your dependent variable over change in your independent variable. So if I do that using these 2 points, I get 18 minus 12 over 50 minus 30, which is going to be 6 over 20, which is equal to 3 over 10. So my slope is 3 over 10. And remember that this is in terms of thousands of dollars. So technically it's 3 over 10,000. And if I wanted to make that a little bit more clear, I could say maybe I could write this as 3,000 over 10,000. So remember that this is change in S over change in A. So what that means is for every $10,000 increase in the advertising budget, the number of sales increases by $3,000. Okay, so we have our slope. Now we just need our y-intercept. So if I want to find my y-intercept for this situation, right? I have my equation S equals MA plus B. I just found my slope, which is 3 over 10, right? That's cool. Now, how do I find my y-intercept, or my s-intercept, I guess in this case, right? What I can do is just plug in one of these points. Either of these points works. I can plug in these values for a and s, and then I'll be able to solve for b. Let me show you what I mean by that. If I take the point 50 comma 18, when a equals 50, s is equal to 18, I can plug in those values. So s equals 18 and a equals 50. And notice that what happens is all my variables disappear except for b. So now I can actually solve for b. And let's see, 3/10 of 50 is going to be 15. So 18 equals 15 plus b. If I subtract both sides by 15, I get b equals 3. So my s-intercept is going to be 3, and my full equation is s equals 3/10 a plus 3. And again, this is in thousands of dollars, right? Okay, so that's my full equation. And what the question was asking was, what are the sales when the budget is $45,000, right? Let me change this to 45,000. What are the sales when the budget is $45,000? So I'm going to plug in a equals 45. Again, I'm not going to plug in a equals 45,000 because I'm representing the numbers in terms of thousands already. So I'll do s equals 3/10 times 45 plus 3. So let's see, 3/10 of 45, I can write that as 3 times 45 over 10 plus 3, which is going to be 135 over 10 plus 3. 135 over 10 is going to be 13.5 plus 3, which is 16.5. So I can say that the sales when the advertising budget is $45,000, the sales are going to be $16.5 thousand, right? Remember, again, this is in terms of thousands of dollars. So the sales are $16.5 thousand, or you could write it as 16.5 times 1,000, right? Which would be, let's see, I think $16,500. All right, so that's the sales when advertising budget is $45,000. Another way that you could have done this that actually would have been easier is, remember, after we found our slope 3 over 10, we still had to find our y-intercept, right? It might have been easier actually to use point slope form. Remember, point slope form is y minus y1 equals m times x minus x1. And in this case, if my y is s and my x is a, I could write this as s minus s1 equals m times a minus a1. And the neat thing about point slope form is that for slope intercept form, you need for this form y equals mx plus b. This is slope intercept form, right? You need the slope in the y-intercept, right? And in some cases that's easy to get and convenient, but in some cases, like in this case, it's a little bit involved and tricky to get, right? But for point slope form, you actually only need the slope and any point on the graph, right? So we already given 2 points from the graph, right? 30 comma 12 and 50 comma 18. So it would actually be pretty easy to plug these into point slope form and get an equation like that, right? So if I were to do that, I know that my slope is 3 over 10, and let's just take 30 comma 12, right, as my point. I would get s minus 12, because that's the s value in this case, right? 12. S minus 12 equals m, or 3 over 10, times a minus 30, right? So that would be my equation in point slope form. And then if I wanted to, I could plug in a equals 45 and solve for s, right? S minus 12 equals 3 over 10 times 45 minus 30. S minus 12 equals 3 over 10 times 15. S minus 12 equals, let's see, 3 over 10 times 15 is going to be 4.5, should be, right? And then if I add 12 to both sides, I get s is equal to 16.5. So I get the same answer either way. But point slope form might have actually been easier to use in this case. But either way, we get $16,500 is a sales when the budget is $45,000. So this would be my answer. Now, before I submit this, I'm going to show you a much easier way to solve this using Desmos. I know that way was kind of long to do, but there's actually a much simpler way that you can do it using Desmos. However, you're still going to need to interpret this this word problem, right? You still need to understand that you can get 2 points from this word problem, right? We got the points 30 comma 12 and 50 comma 18, right? Or 30,000 comma 12,000 and 50,000 comma 18,000, right? Same thing. But if you can identify those 2 points, what you can do is you can create a table in Desmos, and we said our points were 30 comma 12, and also we add 50 comma 18, right? Now you have a table in Desmos, right? What you can do now is create a linear regression, and Desmos will actually find the coefficients in the equation for you, right? So the way that you do that is you type in y1, and then you're going to type in tilde, which is this special symbol probably in the top left of your keyboard, y1 tilde, and then ax1 plus b. And you can see that Desmos is actually going to come up with the coefficients for you. And remember that these are the same coefficients. I think it should still work if I use m. Yeah, same thing, right? Mx plus b, or ax plus b, whatever you'd like to do. I think usually in linear regression they use ax plus b, but it's the same thing if you choose mx plus b, right? The point is that Desmos gave us these coefficients that m is equal to 0.3 and b is equal to 3, and these are actually the exact same coefficients that we found when we manually solved, right? We found that our slope was 3 over 10, which is the same thing as 0.3, and we found that our y-intercept was b, right? So what I can do now is I have my full equation, y equals 0.3x plus b, or 0.3x plus 3, right? And by the way, in this case I'm using x and y. I think that you could also use a and s, right? It's the same thing. Again, in our problem, x and y are replaced by a and s, but you should be able to have that mental map in your mind that a is the same thing as x and s is the same thing as y. But in other words, we get the same equation using Desmos with much less effort, right? And now if we want to find what is the value of s when a is equal to 45, what we can do is I can just plug in, I could just go over here, right? Take this and plug in 45 for x, right? If I do that, I get that the value of y would be 16.5. And that's the same thing I had before, right? By the way, one last thing I'm gonna show you is I could also put in the full numbers. Remember that I'm writing in terms of thousands, right? But I could also, just write the full numbers. So 30,000. Let's see, 1, 2, 3. So I can also write, 30,000, 12,000, 50,000, 18,000. My regression parameters are now 0.3 and 3,000, right? So I would get the same answer, right? If I plug in 45,000 into this equation now, I get that my answer is 16,500, which is the same thing that we got before, right? Again, it's up to preference. If you want to put in the full numbers and solve, I prefer to, truncate it sometimes if it's possible, just to make the numbers easier, but you can also put in the full numbers if you'd like. But either way, we get 16,500, and that's correct.